Good afternoon, Dragons. I am taping you a video as promised. I really wanted to live stream it, and I was trying to figure out how to live stream to the document camera today. And then I soon discovered that you cannot live stream on my work laptop because it has no streaming software. Hi, Anna. I'm taping a video. You're going to be on the video. So, Dragons, make sure you have your interactive notebook. I've got a variety of markers ready for the activity. You'll need some colored pens if you're going to match me. Some tape if you're able to print out the foldable. I'm posting the foldable online. It looks like this. I'll post that for you. And the reason we're doing all of this is to help you with day one of the Durham Public Schools packet. Day one was percent of a number. Now in their packet, they recommend using the bar model and then a multiplication model. Sometimes we call that the equation model. In our studies, we did 3 other models. 2 were very similar. We do a benchmark percent, which involves a lot of mental math and is very advantageous. We do a percent bar, which they call the bar model. Sometimes it's called the bar model, the double number line, etc. The proportion is where the equation model comes in. They kind of shortcut their equation in the packet. I'm going to show you why it really works and show you why this side is truly equal to this side. So I've got Period 4's interactive notebook. And last time we saw each other, we worked on 61 and 62, where we substituted values. This is part of our expressions and equations unit with the algebra. Our review is not going to fall perfectly in our interactive notebook, but right now we just have to go with the flow. I am going to put something on pages 63 and 64 to help with your fundamental understanding of percents. I just don't have those shrunk down for interactive notebook size yet for you. But for 63, I need you to leave a spot, so title page 63, Place Value Chart. We will put something there later. Next, page 64, leave a space for something that we're going to call decimal squares. This is day one's review work. They're coming, DPS is giving us stuff that has to do with fractions, decimals, and percent. Right now we're going to do a flippable called Find the Part. So go ahead, get your title in. Get page 65 prepped and ready to go. I already have my printout. If you are unable to print, that's okay, because in the past we've actually handwritten this foldable. I typed it one year for children with special needs, but you can totally write it out yourself or have a parent help you write it out in the evening when they're done with their work. So whatever you can do to try to work this out. If you also, you could take, print off the picture maybe. Whatever options you have at home. We're all in a different situation at this point. I'm still trying to set up a home office here so that I can teach you guys. So I understand that everything is challenging right now. So I always fold it back on the line first so I know where the fold's supposed to go. And then I fold it forward. It's going to fit pretty nice there. Let me zoom out a little bit so you can see where it's going to fall. So this section we're just going to call Find the Part. Now, you probably can't see it via the camera, but I can see the lines where each section is subdivided. So I'm going to put a title of what each one is. So this one here Just looking through the lines on my printout. This is the benchmark method. Now, if you were unable to print but you found some construction paper, that's a cool option. You could always go with that. This one is going to be where we put the percent bar. And then the last rectangle is the proportion. But a proportion really is an equation. It contains an equal sign, and both sides have balance if you do it right. Voila. I'm going to glue mine in at the end, mostly because I realized the only thing I brought upstairs was tape and no glue. The whole backside can be glued down. Let's take a look here. Find the part. Identify the part, whole, and the percent. Solve for the unknown. These are the fundamental steps. So there's three main situations and problems like these. Like, what is 35% of 60? You do have something that represents the part. You do have something that represents the whole amount. And you do have something that represents the percent. So if I were to own all of it, the whole thing, if I were to own the whole box of crackers, maybe that box of crackers has 60 crackers. That would be the whole amount. If I had the whole thing, like the whole box of crackers, it would be 60 crackers. But then they say, I want you to only count out 35% of those crackers. This is the easier one to find. This one is the percent. The what is the missing component. You have to have all three elements. If we know that the whole box of crackers contains 60 crackers, and we only want 35% of that box, I want to know, what is the part? How many crackers would that be? What does that look like? I'm looking for the part. So this is our thought bubble here. Thinking, and we're thinking what? What are you solving for? Yes, you are solving for the part. I am solving for the part. So in my cracker analogy, that would be how many crackers really represent 35% of a box that contains 60 crackers. Benchmark percent is a percent that is commonly used. You guys were super strong at this concept. 1%, 5%, 10%, 25%, 50, and 100. I'm using the orange marker as a highlighter. In this scenario, 100% of all the box of crackers is how many crackers? If I had all the crackers, I would have 60. And we can just stick with this, like we're thinking of a box of Cheez-Its. We'd have 60 crackers. Let's say I only needed 50%. I said, share the box with your brother. He gets half the box. He would get how many crackers? He would get 30 crackers. So these are examples here. We want to get problem specific here. We want 35% of 60. We're going to have to use some other benchmark amounts to get to 35%. Now, we've made these charts before. a minute, it's probably going to look super familiar. We have a percent, and it's going to represent the amount. And in our example, it's like the amount of crackers. I need to get to 35%. That is the goal. We can piece together to 35% using our 1s, 5s, 10s, so on. The amount, this here, this unknown amount, that will be the part. You will get there. You will get to the part. So then you can piece together simple things. I don't know if you remember the little decimal trick with 10%, but you just move the decimal over once. Like if 100%, let me show it over here. If 100% is 60, 10% would be 6. So it would be just dividing by 10. When you divide by 10, you're really shifting one place value. So 10% would just be 6. I'm going to take a look at this here. I'm going to say, all right, I need 10%, 6. I need another 10%, another 6. I need another 10%, another 6. And I need 5% more to get to 35. Well, 5% is half of 10%, so I need half of 6, which is 3. I've got all these little parts that are going to add up to all the crackers that you're going to share. You're going to share 35% of the box. 6 plus 6 plus 6 plus 3. You would share 21 crackers. Next up is the percent bar. The percent bar is a visual model that compares percent to amount. Percent bar is like a double number line. We're a big fan of double number lines. They are super cool and useful. They help us conceptually understand the math. I'm going to show you one that I'm going to make here. Do the best you can. I haven't done this in a while, so I'm going to look at my notes. I'm going to make you a pretty percent bar. All right, I drew you a rectangle. I hope you're impressed. The top part we can label as amount. That would be like the top number line. And the next number line will represent the percent of the amount. So if you're starting here, you're starting at nothing. You are starting at 0%. And since I'm only illustrating one bar for you, the whole bar is worth 100%. This is where you can use a lot of scaling up and scaling down that you learned in ratios. First, I can start to think of some items that I know. For example, I know that if I have the entire box of crackers, I have 60. And 60 represents the whole. I'm in search of the part. And in fact, I haven't even illustrated where 35% would fall in my world here. I do know where 50% would fall, and that helps me as a guideline. We don't need half of the box. We actually need a little bit less than half of the box. I don't even need you to divide it perfectly because this is more of a sketch. It's not an exact. It's not scaled to exactness. Now we need to think of an easy way to get to 35. Let's say 35 falls, I don't know, right about here. We're just making a really educated guess here. And I want to use one of my smaller benchmark fractions that can help me scale up to 35. Oftentimes we like to say 10, but 10 is actually not friendly with 35. 10 does not go evenly into 35. It doesn't work friendly. So you have to think of another one that would be friendly. What friendly benchmark percent works nicely with 35? Perhaps is a factor of 35. If you said 5%, you did excellent work. So I'm going to find what 5% is. Well, we know 10% is 6, so 5% must be 3. Another way to look at it is 100. How did you get from 100 to 5? 100 divided by what gets you 5? 100 divided by 20 gets you 5. Well, if I do that to that one, I have to scale this one down the same way. 60 divided by 20 gets you 3. So that's another route to go to figure out what 5% was worth if you did not know the benchmark. Now I want to scale up from 5% to 35%. I want to go from here to here. What do I have to multiply by to scale from 5% to 35%? Times 7 is correct. Good job. Which means I'm going to do 3 times 7. And I'm going to get the missing amount here. The missing amount could be x. X in this scenario represents who? Who are we hunting for this whole time? If you said part, you are correct. X will be the result of 3 times 7. It's 21. So what does that mean in the big scheme of things? It means that you have found a portion of the whole. I want to shade that for you. Give me a second to get a pencil. If I had the whole box of crackers, I would shade the entire percent bar. If I had 50% of the crackers, I would shade half the percent bar. I have neither of these. I have 35% of the crackers. So I'm going to shade 35% of the box. You're going to share this many crackers with your sibling. They get 21. You get the rest. So now we've covered the benchmark percents, which is we can make a list, add it up, bing, bang, boom. Percent bar is a visual model that helps you scale up and down using ratios and proportions. Or we can go straight to the proportion that is used as an equation. Remember, a proportion is two ratios that are set equal to one another. What's great about the proportion model is that it has components directly from the problem. Like, you know you're looking for the part. You know in this one how much the whole is. Percent means out of 100. So you're going to write the percent, not including its percent symbol, because that would be like saying percent twice. We don't want to do that. So it's in fractional form. You're going to have your percent over here. You'll end up with something that looks like a fraction over here. And since they are set equal to one another, they will be, in fact, equivalent fractions in the end. So let's see how that plays out for us. We're going to think about where everybody would live. It's somebody equal to somebody. We're going to put in who we know. We know the whole. The whole lives here. And perhaps this will be helpful for you. I'll go ahead and fill in the parts again. Remember, we need to have part, whole. I'm just using the diagram that is directly to my left-hand side. The percent, and a percent is always placed over 100. So the part is the unknown. We don't know him yet. We've solved them twice before, but we're trying a new method. The whole, the entire box of crackers, would be 60 crackers. If I own all of the crackers, I have 100%. 60 is to 100 as something is to, we know we are looking for 35. We know this. Now, scaling between 60 and 100 is not fabulous. They don't work that great together. 60 is not a factor of 100. So a lot of people like to scale this particular problem down. So we could scale this down here, and we could get to something that would work more friendly with 60. So let's divide by something to scale down. Divide by something to scale down. 100 divided by 5, perhaps, would get you to 20. If I'm going to do 100 divided by 5, I have to be fair because I need to maintain equality. I'm going to do 35 divided by 5, which is going to get me 7 over 20. So what I just did here was I scaled down. Why did I scale down? Because I wanted to get to a factor that would be friendly with 60. We want it to work nicely. 100 and 60 were not compatible at that time. Now we can scale up from 20 to 60 quite easily. 20 times 3 is 60. I'm going to scale this one all the way up. 7 times 3 is 21. So your unknown number is not so unknown. We're going to scale up. So, what did you just find? You found the part. You found how many crackers out of the Cheez-It box that you have to share with your sibling. So, once I get my hands on some glue, I'm going to glue this guy down. Feel free to cut the parts, or you can leave it open, however you'd like to do. Last year I did cut the sections. This is my last year's model. So you can just open up whichever section you want to use, which one's easier for you. And this is going to help you with this. And I will work through this packet and post answers as I get the answers as well. So right now, you've completed page 65 of your interactive notebook called Find the Part Flippable. I hope this was helpful information and was a good review for you. And I will be back soon with Find the Whole, which corresponds with day 2 of the Durham Public Schools review packet. Thank you, Dragons.